All right, welcome back. Happy Wednesday. It's our third Monday off in a row, I think. So I'm kind of getting used to. Next week when we have to be here 5 days, that's just going to be like, wow. Yeah, let's just do can we just agree no Mondays? All right, so today we are covering something called integration by substitution. It is so important that on Friday we are also covering integration by substitution. 2 days on one topic gives you a sense of its utility to us. Quiz number 2 is officially due. That's the derivative formulas. You have already graded them, hopefully, yourselves. Just throw them in the green folder. If you forgot about it or you're not quite happy with your grade right now, stick around for a little bit after class and do it right after class, okay? Want everybody to do well on this thing, hopefully hundreds all around, lots of formulas that we're going to use, so I wanted them memorized. All right, let's see. Coming up on Friday, project number 2 is due. This is the one about the Gini index and Laurent's curves, okay? So the project is due on Friday. You can pass it in right now, and I will ignore it until Friday. All right, so the project is due Friday. I will hand out project number 3 on Friday, which is my reminder to print project 3 before Friday. Any questions on the calendar? All right. Okay, so again, let's jump in on page 58. Here we go. There we are. All right, daily summary. Haley, could you read the summary? Yeah, and I want to be clear, it's not just the most important one so far, and we're going to see something bigger and better later in the semester. This is as good as it gets right here. As far as integration techniques go, this is the most important one ever. Susanna, number 1. Thank you. Rich, number 2. Great. So you guys have a quiz that you just put in there where you memorized a handful of integration rules, but in the grand scheme of things, that's a pretty small collection of antiderivative formulas that we have. And this is about to grow that collection. So we're actually going to skip 3. We're going to come down here and jump straight to 4. Let's give it a shot. So we're going to find the integral of cosine of 5x dx. Is this one of the few things on that quiz that you turned in? Cosine of x dx is in there. Is cosine of 5x dx in there? No, so we're out of luck, right? If it's not on the list, we don't have a way to do it at the moment. So let's give this a shot. We are going to make a substitution, and the substitution we're going to make is letting u equal 5x. We just pick a letter u. That's oftentimes the one we pick. Don't worry about that choice. The 5x is the thing that's in the parentheses there. I will give you some insights into how to decide what to let u equal. Yeah, u is the stuff. It's exactly the same word we used last semester. What about sine of 5x? Sine of 5x is not the right answer. It's a good thing to try though. Like what if we just tried sine of 5x? What should I do with this to see if it's the answer to that integral? Take a derivative. And if this is right, then what are we hoping to get over there? Hoping to get cosine of 5x, right? If this is the right answer. So what's the derivative here? Okay, let's see, cosine of stuff, but then times the 5, and it's that little 5 that isn't there, and it's not hard to fix it. It's just a constant that we got to finagle. Yeah, there's going to be like over 5 is going to be in the answer. That will be our final answer. Is cosine of 5x. That's the very reasonable first attempt, but then we need an over 5 to kill the 5 that we know is going to come in from the chain rule. All right, so the technique we're going to go over here will get us to that answer, and it's a very methodical, procedural technique. So even if it's not as clear as this one, where it's like, oh, I can kind of see I just need a 5, and so I'll put an over 5. This technique will get us there, even when they look more complicated. Okay, so the next step is to take a derivative of this guy. So I'm going to write it like this, and then I'm going to make a slight change. So you can pause on writing this for just a second. So the derivative of u with respect to x, that's what that symbol means. What's the derivative? 5. And then all I'm going to do is I'm going to treat this du dx like a fraction, and I'm going to put the dx over there. And I'm just going to do that in the very first step from now on. I'm not going to write the du dx. I'm just going to write, okay, it's 5 and then dx. Okay, and then I'm going to give a name to this original thing. I'm going to call it I, just so I can reference it down here. So I equals, and what we're going to do is begin to substitute. No funny business here. Term for term, everything in the original has to get replaced down here with something. Okay, let's see. I see cosine of 5x. Oh, good. I have a shorthand name for that. That's really cosine of u. Yeah? Okay, so we got cosine of u. And then I'm going to go back to that original integral, and I'm going to underline everything that's in the original that I haven't replaced yet. There's only one piece. Is the dx, right? That's the only thing that's missing. This dx right here is the only thing that doesn't appear at the moment. So my job is to find that underlined thing in this equation. I've underlined it again. It's right there. And so if I want to be able to substitute, if I want to change that original dx into something else, all I have to do is solve that blue-green equation for the dx, yeah? Is du over 5. So this guy becomes du over 5 is equal to dx. Du is just the symbol that says the derivative is being taken with respect to u. Everybody see why we solved for dx? That was the one thing in the original that hasn't been replaced yet in the new guy, in the new integral. And I want to substitute for it. So let's solve for the dx and then substitute in. So then we're going to I'll underline it in purple one more time. Instead of dx, what did we discover is the same as a du over 5. Yep. So term for term, would you guys agree that everything in that original integral is down here? It's all equal, just some symbols have shifted around, but there's no funny business. Everything is there that was there before. Some of it just looks a little different. Okay, so that divided by 5 is a constant multiple. Where can I put it? I can put it in the front, and what does it become when I pull it out? 1/5, right? It's on the bottom. It's not a 5. It's a 1/5. And then I'll copy everything else. Cosine of u du. What was that? Yeah. Okay. So we did a lot of stuff. Integral of cosine of u du. That's on your sheet, right? That's one of the ones that was on your quiz. It's not cosine of 5x anymore, which isn't on your sheet. It's cosine of plane u, which is like plane x. And what's the integral of plane cosine? It's sine. So it's sine of the letter, which is u in this case. 1/5 was just there. And again, the symbols mean the most general antiderivative, so at the end, plus c. Good. And then, yeah, like we can't leave this as our answer. The problem had x. We invented u to make it so that we got to an integral we could handle. So now we just go back at the very end. So this is equal to 1/5 sine of, instead of u, 5x. So there's our answer. Yeah, so here's my general answer to that question. I am providing a very detailed, like step-by-step approach. Ultimately, I just need you to be able to figure out how to get to the answer. And to be honest with you, with practice, a bunch of you are going to be able to kind of do a lot of this in your head and just get me to the answer, which is super. So my goal is not to make you like write tons of stuff that you don't need. My goal is to make sure that everybody has a way to get to the answer. And they're going to get more complicated. And so my recommendation is to take this methodical step-by-step approach until you feel really comfortable with everything, right? Until you start to get this intuition about, okay, the 5, let's see, I need a 5 because it's going to pop out when I take a derivative, so I need a 1/5 is this opposite business. But if you're just like randomly putting in 1 over whatever that number is, but it's just kind of hazy to you, why? You're not going to be doing well when we get to more complicated integrals, right? So I'm not forcing this, but I'm recommending you go with it until you're really comfortable and have that intuition under your belt. Okay, so we're going to pause on this. We're going to jump back to page 1. So let's go all the way back to the very first page. And on the front of this first page is a reference sheet with lots of antiderivative formulas. And you're going to have this reference sheet with you on tests and quizzes. And then on the back is a U substitution step-by-step process written out, which you will also have with you on tests and quizzes. So we are just going to quickly run through this guy. This is just going to be kind of like show and tell. I'm not really going to write anything. I'm just going to do a lot of pointing. So here's the original integral. Notice that I've called it I just so we can reference it later on. So there's my integral. And we're going to let U equal this complicated stuff that's inside. And I'm just going to say inside is generally where I look for the U. On the first example, it was cosine of 5x, right? And that 5x was inside. So with the inside piece here is this 3 plus 4x cubed. What is it inside? It's inside of a 5th power. So that's a natural choice to make. So we let U equal just the stuff on the inside, not the 5, just the stuff on the inside. Okay, and then we take our derivative. So the derivative of this guy right here is 12x squared. So that's written there. But then remember we said we were just going to take that we're going to take that dx. Actually, I didn't quite write this exactly the way that I wrote it before. So I'll add this one thing. You're welcome to add this if you wish. Just moving that dx over to the other side. And so then we start, I'm looking at this and I haven't looked at this in a little while, and I actually wish I would have changed this because I'm not thrilled with the way this is written. So here's the part that the mathematician in me does not like, is that we have an integral here with x's and with u's, and that's a problem. Now it's true that the x's cancel, and you just get u's, which is ultimately the goal, is to just have an integral with u, but x's and u's together is not like mathematically correct, even though the x's cancel. So can I keep writing in blue here, like the kind of analogous thing to what we did before? Okay, so let's, in blue, I equals. All right, so we're going to go up to our original integral. We're going to get u in there the easiest way possible. So I'm not going to copy that x squared for now, but I am going to replace the stuff in the parentheses with u, right? The entire thing, including the x squared. So we're going to get our u in there as easy as we can, and it's a u to the 5th, yeah? That's just changing the thing that we named u into u. And then I'm underlining in purple everything that's in the original that isn't down here yet. So what's in the original that hasn't made it here yet? X squared and also dx. And x squared dx is the thing we need to find in that derivative equation, right? And what do I do to both sides to solve for that purple underlined thing? Just divide by 12. And so then this guy becomes du over 12 equals x squared dx, underlined in purple. Okay, and so now going back to this thing we called I, all we have to do is put right in here the stuff that's the same as what's underlined in purple, du over 12. And so again, you should confirm that everything in the original integral is now in the new integral. No tricks. We would be out of luck. We'll see one in a second where we're out of luck. Just sometimes will. According to the problems in the homework and on tests and quizzes, it's going to appear that it will cancel almost all the time. But that's because they were specifically chosen to be so that the integrals would yield to u substitution. Oftentimes there is only one u that will get you there. So you guys are asking good questions about, well, what if this and what if that and how, and so we're going to see some integrals where it just isn't going to work. And so hopefully that will answer some of these questions. So you got to pick, you got to pick the right u. It's not just like pick any old u and then follow the bouncing ball. I mean, like you got to pick the right u. Yes, and this technique did not work. If the x's don't cancel, the technique didn't work. No, exactly. It's got to be just one letter there. X with dx, u with du, but no mixing and matching. All right, lots of good questions. What constant can I take out of this new integral? 1/12. And then we've got this integral of u to the 5th du. And then mercifully, an integral that was on your sheet, right? This is just u to a power du, which is one of the very few things. I say few, there's like 10 things we know how to do, and you got to try to get to one of those 10 things. Okay, so I always forget, do we add one or subtract one from this power? Add one, right? U to the 6th divided by the new power or the old power? New one, right? 6. Plus c is there. And then last step is to change the u back into whatever it was. We're done. Just plug it back in. I'll merge the 6 and the 12, so that's a 1/72. And then instead of u, we're going to put whatever it was, 3 plus 4x cubed. And that's now raised to what power? To the 6th plus c. All right. Does it always come out as, say it again? Oftentimes it comes out that way. Sometimes the constant is a little bit more involved than that, which is why I kind of give this step-by-step procedure. Well, we're going to see lots of examples. I promise. Once you've got what you need on this page, jump back to page 58. Actually 59, we'll go to the very next page. Okay, let's go to Stefan. You're next, number 6.
As to when you substitute that sometimes there's a file error involved. This is the one sometimes you can't listen and not unless
Part of the other. Okay, so let's take a look at these 4 examples here. We're going to just do the choice for u, let u equal the inside function, and we're hoping that the rest of the integrand is basically the derivative. Okay, so what's a good choice for u in this first example? X squared plus 1, right? Because that's the inside. And if you just mentally take a derivative, what do you get? 2x. Fantastic. 2x is exactly what's sitting out there. So that is just going to become a straight u to the 50 du. Super. The next one. Let u equal the thing inside. What is it? 3 minus 5 t to the 5th. What's the, sorry, I was answering part of my question that I was about to ask. What's the derivative? Is essentially t to the 4, right? And Rob didn't even bother saying negative 25 because that number doesn't make a difference. It's the t to the 4th-ness that we're after. And so the derivative of this guy is just some multiple times t to the 4th. Super. That's exactly what I have out in front there. So that t to the 4th is going to be part of the du. There's going to be an over something, but we can deal with it as we go through the process. This guy is a little bit tougher. it seems like I have two choices. Like I could let u equal the top, or I could let u equal the bottom. The bottom is almost always the right answer. But like I said, we don't have intuition about this kind of thing yet. If you just let u equal the top, then what's the derivative? 1, does that look anything like the stuff that's left over in the bottom? No, so this isn't going to work, right? It's not going to look like a u times a du with a constant. Okay, so let's try the other option. It's not clear to me this is going to work, but it's the only other thing we can try. What is the derivative here? 2x plus 10. Don't forget we're moving that dx over. Is 2x plus 10 a multiple of the rest of that integral? It is, right? It's just double. Yeah? And so it's going to work because the stuff that's left over is just essentially du with the constant that we can figure out. Your antiderivative of your u? No, I think for this guy, so here's, I'll just do little highlights here. So this integral would become, where is the u, top or bottom? The bottom. Okay, so we put it in the bottom and then we don't do anything else. And then we underline what's in the original that isn't here yet. What is it? X plus 5 times dx. That is what I'm after. So my goal is to build x plus 5 dx from that equation. What do I do to that right-hand side to turn it into an x plus 5 dx? Is I divide it by 2, yeah? And so all of that stuff, the x plus 5 dx, is really the same as du over 2. Super. So then that's what we can put right up here as a du over 2. Pull the 1/2 out. 1 over u, fortunately, is one of the 10 things we know how to do. It's ln. Right? Another reason that if you have a top and bottom, oftentimes the bottom is the right choice for you, because if you can make a 1 over u with the du, then you've got an ln. Then we're out of luck. Again, these are going to be chosen so that things will work out magically. Number 7 is not going to work. D. Yeah, you could let u equal 4x. I want to be even more greedy. I want to pick the biggest inside function, e to the 4x, right? E to the 4x is inside. Now, there's 2 copies of e to the 4x in this thing. I don't know why there are 2 copies. I'm picking the thing that's inside, right? The other one, I don't know what's going on there. Right, and so if we take a derivative here, what's the derivative of e to the 4x? Is e to the 4x times 4, and then don't forget that dx. So this piece right here becomes sine of u, and then everything else is basically your du, and there'll be a constant floating around. Okay, so here's the thing in bold. We're finished at this table. Sephora, can you read 7? Right, u's and x's together is no good. So let's see what happens when we get u's and x's together. Okay, what's maybe our natural choice here for u? Is x to the 4th, the sign, the thing inside of the sign. Again, there's oftentimes more than one natural choice. So you make one and you try it. If it doesn't work, you try another one. But this seems like a good choice because it's inside of sign. And so if I take a derivative here, I get 4x cubed dx, yeah? And so then we will start replacing. So the integral becomes, all right, so just trying to get the u in there as simply as possible. So sine of u, yeah? And then we're underlining 2x and dx, right? And so my goal is to build a 2x dx somewhere inside of this thing, and I can do it, right? How can I turn the 4 into a 2? What do I multiply or divide by? Divide it by 2, right? I'll take care of that. What do I divide the x cubed by to give me just the single x that I want? X squared, great. So we're going to divide both sides by a 2 and an x squared because that's going to build that purple underlined thing. Divide by 2 and x squared. So that means that du over 2x squared is equal to, okay, so then the 4 and the 2 cancel, make a 2, single x left over, dx is there, lovely. That's exactly what we had underlined. So then we can replace in the original integral, all that underlined purple stuff becomes du over 2x squared, right? Exactly what it's equal to. Du over 2x squared. And so all of the other problems at that point, we just took a constant multiple outside. But that x is not a constant multiple. The paper just explodes in flames. It's like, you don't want to do it. It's not something you can do. Yeah, I mean, if you take a variable out of your integral, you're changing the value of that expression. So we just can't do it. Okay? Yeah. And so, like, I don't want to say, like, this is the end of the road. I'm just saying for this u substitution, it's the end of the road, right? Maybe some other technique, but this didn't happen. Okay? If you get u's and x's together, try something else. Okay, so finally, number 8. Let's go to Dean. Okay, so group activities are here. Again, I encourage you to follow the process, write out all those steps. Don't let anything be murky.